Okay, in this session, we are going to discuss about uh, the chapter motion in a plane. Okay, and it starts with the introduction to 2D motion. So this is not any complete different type of motion and all those things. Simply, 2D motion is all about breaking of. It's a just next version of studying of 1D motion only. We have to study the 1D motion only in different directions, like 1D motion in x-axis and one dimensional motion in y-axis. Okay, so both these has to be solved using the equations of motions along x-axis and y-axis, whichever that we were using in one dimensional motion only under the constant acceleration, whichever that we were using. Okay, and if I have to take some simple examples of 1D and 2D motions, so we can take a very simple example. If an ant is moving on a if an ant is moving on a stick, let's assume. Okay, if an ant is moving on a stick, then it has no other dimension, or else we can say it has to move on that stick only. Okay, right? That is example of 1D motion. Now if an ant is scrolling on wall, so you can imagine, it's a bit difficult to draw the figure over here, but you can imagine the ant can move in two directions. One, it can move along x-axis, maybe forward, or else it can move upward, maybe downward also, right? Or else it can go back also. That means along x-axis, this is one direction. Along y-axis, it is another direction, right? So it can move in two directions. So it has a freedom to move in two directions, x and y. Whereas in 1D, it has to move maybe forward along positive x-axis or else negative x-axis. That means it is restricted to move only in one dimension. That's all about the some simple example of 1D and 2D motion. Okay, so in our textbook we have to go through two standard equations, so two standard examples, that is projectile and circular motion. Projectile and circular motion are the standard, and we have to write each and every 1D equation of motion in terms of both x and y axis. And before we start solving problems or the concept, we should have a proper idea about the complete vector analysis. Okay, so it's a mandatory to go through each and every concept related to vectors before we start solving the problems related to motion in a plane. Now, equation of motion. What are the equation of motion? How can we write the equation of motion over here? Simply so I will just take one example, that is we know v is equal to u plus at. Now if I have to break the 2D motion into 1D and 1D along x axis, so like this, along y axis vy plus uy plus t. Now in vector format, I can write v as vx I cap plus, this is uy, sorry, j cap. Similarly, everything same in a similar way we can write second equation, third equation, everything can be written like this. Okay, v square is equal to u square plus 2as. So all the three equation of motion whichever that we were using in one dimension can be used in two dimension also. There is no separate equation over here to find the, and all are independent. So a very important thing which has to be remembered over here is that x u, that means uh, distance, displacement, initial velocity, velocity at any time, acceleration, everything along x-axis is different, again along y-axis it's different. So all are, these are independent terms. Okay, they are independent on, they do not depend on each other. While calculating the velocity along the y-axis, we need not to worry about the velocity along the x-axis. Okay, while calculating the range, we did not to worry about the variables given in the y-axis. That's the beauty of this 2D motion. Okay, we need not to confused. We need not to get confused. We will see that through taking some examples also. This is just an introduction. Now, now the next topic is, it's all about, we will try to understand how to solve the problems in in first example, projectile motion. Okay, so let me take one example. I will try to explain the theory along with this example. Okay, the first problem is that, so in this problem itself we will discuss all the possible theoretical aspects related to the projectile motion. The question is that a particle is projected with, a particle is projected with velocity 100 meter per second at an angle of 53 degree at an, so now angle of projection 53 degree. Okay, with the horizontal. First thing is, find initial velocity in vector form. Find u in vector form, or else simply u only. Okay, let's try to understand the how can we describe the motion along y-axis, along x-axis. Right, now they have given u as 100 and the angle theta is 53 degree. So we know that this will be, so using vector resolution of vector components, easily we can write this as ux cos 53 degree, and along y-axis we can write this as uy sin 53 degree. Right, so now using the basic knowledge of trigonometry, we can solve this one. Right, so 53 degree, we know 37 degree, 3 4 5. We have to memorize these results of 37 and 53 degree. That's a trigonometric ratios. So if you just memorize it for 37 degree, that is sufficient. 3 4 5. So sin 43, sin 53 degree will be opposite side by this one, so 4 by 5. So uy into sin of, if you substitute all these things over here, what will happen? Again, cos 53 degree is, cos 53 degree is nothing but 3 by 5. Sin 53 is 4 by 5. Okay, so that ux into cos 53 degree will be 100 into 3 by 5. 100 into 3 by 5 is 60. Right, similarly this one will be uy, that is 100 into sin 53 degree, that is 4 by 5. 5 ones the 520 is the, so 20 into 4 80. So this is 80 and this is 100. So in vector format, how can we write the ux? Sorry, become ux is, we know that, as I told you, initial velocity along x-axis, it has nothing to do with the initial velocity along y-axis. All the, not a velocity, acceleration, next distance, displacement, everything. Okay, uy into j cap. So what is ux? That we already calculated. That is nothing but 60 I cap plus uy is 80 j cap. So we got the expression for this one. What is the angle of projection? They already given angle of projection is 53 degree. No issues. So in this way we can find out what, okay, velocity after 2 seconds. This is velocity at t is equal to 0, right? Similarly we can find out the velocity after 2 seconds and all those things. Before that we will calculate some more basic aspects. Okay, we are done with the velocity. If we have to, just a second. Fine. Y-axis and x-axis. First we will try to describe the motion again. Fine. So we already calculated u. So angle of projection is 53 degree, right? U, that is nothing but 100. This is 60 along y-axis, that is 80, right? Now how this is going to vary? So we know that the velocity after some time it's going to decrease up to maximum height. This is nothing but the range. Range is nothing but what? Maximum horizontal distance which can be traveled by the object, right? Now as this object reaches here, what will happen? The horizontal velocity remains as it is. Okay, why does it remains as it is? Throughout the motion, wherever you see it, so this horizontal velocity remains same. Even in textbook also you will find this type of figure where horizontal velocity remains same. So vx or as ux is nothing but vx, that is constant. So they do conclude ax as 0, because we know that a is dv by dt, and if there is no change in velocity, that means acceleration must be 0, right? Oh, because see, the object is moving along the x-axis due to inertia of motion. There is no external force acting on it. Okay. Hmm? So there is no, if f net is 0, that means a is also 0. In that way also we can understand. Whereas in along y-axis, so suppose this is after, so this one, so here vy is equal to 0. Slowly the magnitude of the velocity along y-axis get decreases because of the acceleration due to gravity, right? Because of the acceleration due to gravity. So vy varies due to ay g. Okay, again here acceleration along x-axis is independent of the acceleration along the x-axis. Again it is constant, right? So everywhere, everywhere this what acceleration due to gravity remains same, minus g throughout motion it remains same. So this is all about the variation of the velocity. How does the velocity varies throughout the motion? Now if you have to calculate the exactly, so we can use the basic formula v is equal to u plus at. Like after 2 seconds what would be the velocity, after 3 seconds what would be the velocity, after 4 seconds. Based on that, for that we should have the knowledge of complete time of flight, right? Time of flight, once again, along y-axis, x-axis, right? So what is the time of flight if I throw an object with 100? If I'm going to throw an object with the initial velocity 100, what is the uh, total time of flight? Okay, first we will start with how much time it will take to reach the maximum height. So we can use the basic thing. Just a second. Vy is 80. We already calculated. This is 60, right? So uy is equal to plus ay into t, right? What is vy, which has to be calculated? So whenever it reach maximum height, vy will be 0. Vy will be 0. So uy we already calculated 80, and ay is, see, in every place the acceleration remains as minus g only. Ay is minus g, whereas ax is 0. Everywhere ax is 0. Now we are talking only about ay. So ay is minus g, that is 10t. So 10t is equal to 80. So t is equal to 8 seconds. Again, to come down it will take 8 more seconds, right? That is the concept of symmetry that we already studied in, so 1D motion. So the total time of flight is nothing but 8 plus 8. Total time of flight is 8 plus 8, 16 seconds. So in this way we can calculate the, so without formula also we can calculate it, just orally also we can calculate it, like, okay, the velocity, initial velocity along y-axis is 80. So whenever it reaches the h maximum it becomes 0, and g is 10. So that means for every second velocity is decreasing by 10. So after 8 seconds, so after how many seconds it will become 0? So definitely that is nothing but 8 seconds. After 8 seconds, so like, see, just a second. Now see the after, let me take after, suppose after t is equal to, after t is equal to 2 seconds, after t is equal to 1 second, let it take. So 80 will become 70. Now after t is equal to 2 seconds, 80 will become 60. So 60, 50, slowly as it reaches over here, Vy will be 0. Okay. Whereas velocity along x-axis, it remains as 60, 60, 60 only throughout the motion, which has to be remembered. Again, if they ask question, what would the velocity after t is equal to 6 seconds? Suppose velocity at t is equal to 6 seconds. So we can find the expression for velocity using the what, equation of motion also. So but now we just orally we can calculate it very easily, right? Now see, after 6 seconds what would be the velocity? Now it is 80. Again, at t is equal to 8 seconds, it is reaching here, so this is wrong. So after, we can ask question, after t is equal to 10 seconds, what would be this one? Again, at t is equal to 10 seconds, it v is 0. Again the acceleration is increasing by 10, sorry, velocity is increasing by 10 per second. So uh, on 8 second velocity is 0. Now on 9 second velocity will become 10. Again 10 second velocity will become 20, right? So slowly it's going to increase now, but in a opposite direction, which has to be remembered very well. Okay, using unitary method also we can calculate the velocity, or else we can use the equation of motion also. I will show that one also. Now this is all about the variation of velocity. How does velocity varies along x-axis and y-axis, and how to calculate the time of flight. We have separate formulas for to calculate the time of flight, range, that is horizontal, and h maximum and everything. Now just to basic, I'm just trying to explain, just on the basis of 1D motion knowledge also we can solve the problems. Okay, many problems can be sorted out in this way. So that was all about the velocity and the acceleration along x-axis and y-axis, and we have covered the concept of time of flight also, right? Okay, so we have calculated time of flight, that is 16 seconds, and let me write the results that we have calculated. U is equal to uxi plus uy j cap. What is ux? Ux is 60 I cap, because u is equal to 100. So second is all about the acceleration. Again, acceleration along x-axis is axi plus ay j cap. Okay. What is axi? So along ax, it is velocity constant, so it is 0, right? Plus along ay, it is nothing but minus 10. Now we are, instead of 9.8, I am taking 10. Okay. Next, C, time of flight, that also we have calculated 8 plus 8. Using unitary method we can calculate it, or else we have different formulas also. If displacement uh, is given, then we can use displacement and u is given. If s and u is given, we can use s is equal to ut plus half at square. Hmm? Or else v is, if u and u is given, we can use v is equal to u plus at. So in this way we can calculate the time of flight. While solving some more problems, we will discuss more about that. But the best thing is to go with the without formulas. In entrance exam we have to save the time. For that, better to use the unitary method. Very quickly we can solve that one. Now what would be the range? Range is the, what is range? First of all, that is nothing but maximum horizontal distance. Maximum horizontal distance. Once again we will learn everything about horizontal range. Now this is just without memorizing the formula, just basis of, on the basis of 1D knowledge, how can we calculate the range? Range is, we know that uh, this is nothing but what, sx, so ux into t plus half ax into t square. Okay, what is ux? Ux is, if we just look into the data, we got ux as 60. Okay, what is the time of flight? So now here in t, don't put this as 8. What is the total time of flight? How much time it will take to reach the maximum height? Okay, sorry. So if this is range, we have to consider what is the ax. We know that is 0. So if ax is 0, everything will be 0. So range is nothing but simply ux into t, right? Again, that in terms of theta also we can write ux u cos theta into t. Again we can substitute the value of time of flight also in terms of theta. That hrt, height, range, time of flight, we will discuss after this. First we will try to understand how to uh, solve what 2D problem, just basis on the knowledge of 1D motion. So 60 into 16, that is 260, 16 into 960 meter. This is the what, horizontal range. Without memorizing the formula also we can calculate the, just we are using the, our base is fundamental equation of motion. Okay, nothing else we are using. Now find the velocity of the particle. As I told you, velocity at 2 t is equal to 2 seconds. Velocity at t is equal to 2 seconds will be v is equal to vxi plus vy j cap at t is equal to 2 seconds. We already got u is equal to 60 I cap plus 80 j cap, right? At t is equal to 0. Now for vx and vy, see I already explained you how can we do this one. Vx always remains constant. Okay, so vx is remains throughout the motion, vx remains constant, that I already explained. And vy, again unitary, using unitary method you can calculate it, or else we can apply the formula. Vy is equal to uy plus ay into t, right? What is uy? Uy is nothing but 80, and ay is minus 10, that is g, and after how much second? 2 seconds. So 80 minus 20, that is 60. So at t is equal to 2 seconds. So Vx 60, this one. So V at t is equal to 2 seconds. At t is equal to 2 seconds, what would be the value of V? V is nothing but Vxi plus Vy j cap. So 60 I cap plus 60 j cap, right, at 2 seconds. Now, so same thing, if I increase the time, suppose at t is equal to 12 seconds. If t is equal to 12 seconds, again Vx will be, it remains constant, so that is 60 only, whereas Vy will be what? So directly also using orally we can write it. Okay, in case if that is going to create confusion, so simply substitute the formula, that is uy is equal to 80 minus 10 into 12 seconds. So 80 minus 120 minus 40, right? So v at t is equal to 12 seconds is 60 I cap minus 40 j cap. Okay, next one, we are just trying to calculate the maximum parameters based on a single problem only. Okay, we can find out the average acceleration also. Average acceleration is what? Change in velocity divided by del t, right? Average acceleration is change in velocity, that is Vf minus Vi divided by t. T2 minus T1, that is actually 16. So what is Vf and Vi? Final velocity. Final velocity means velocity at t is equal to 16 seconds. Velocity at, because total time of flight is 16 seconds, so what is the velocity of landing they're asking, that is final velocity. Velocity of takeoff is initial velocity. So we can use the formula v here, what, sorry, which has to be Vx I cap plus Vy j cap. So we know that Vx always remains same, it is constant. Okay, only Vy varies along with the time, that is Vy is Uy minus this one, Uy minus of gt. Uy is, what is the initial velocity component along the y-axis, that is 80. So 80 minus 10 into 16, 80 minus 160, that is minus 80 is the answer, that is the this one. So final velocity can be represented in this way, 60 I cap minus of 80 j cap, right? So initial velocity, that is already given, 60 I cap plus 80 j cap. So del v is nothing but 60 I cap minus 60 I cap, that is 0. So 80 plus this one. So change in velocity based on Vf minus Vs is 160 j cap with minus sign. Now if we substitute this one over here, so we'll get minus 160 divided by 16, so minus 10 j cap. So in this way we can calculate the average acceleration also, average acceleration, change in velocity. Now this is all about the variation of velocity and acceleration and time of flight. So hmm, now if I have to discuss more about all those things, what are the other parameters which can be calculated in this way? Just a second. We can calculate some more parameters. That is nothing but we can find out the location of the particle, right? Location of the particle at t is equal to 2 seconds. So write down the question. Find the location of particle at t is equal to 2 seconds. We already calculated the velocity at t is equal to 2 seconds. In the same way, the next parameter is find the velocity at t is equal to 2 seconds. So along y-axis, x-axis. So we already seen that it takes 8 seconds to reach the maximum height. So t is equal to 2 seconds means somewhere in between this one, right? So after t is equal to 2 seconds, horizontal velocity remains same. That is nothing but what? Okay, if we have to calculate the location of the particle at any particular time, again we can use the equation of motion only, right? We can use s is equal to ut plus half at square to calculate the location, right? We can use the equation of motion s is equal to ut plus half at square. Again, displacement along x-axis is nothing but sx is equal to ux into t plus half ax into t square. So as ax is equal to 0, this is nothing but t only. Ax is 0 along x-axis. We know that the velocity remains constant, so ax is equal to 0. So ux is, in our problem, ux is nothing but 60, and they are asking about at t is equal to 2 seconds. Suppose this is at t is equal to 2 seconds. So in beginning at t is equal to 0, 60, and this is 80, right? So 60 into 2 is nothing but 120 meter. Similarly, sy is nothing but uyt plus half ay t square can be used. Uy is nothing but 80. So after 2 seconds, that is nothing but 80 into 2, 160, and this is 1 by 2 into 10 because ay is minus g. So t square, that is 4. It's all about simplification. 5 4 is the 20, 160 minus this one. So sx and sy at t is equal to 2 second, both are 120 meter only. 160 into 2. 80 into 2 is 160. That is correct. 2 square is 4. Sorry, this is 140. So the location of the particle after this one is nothing but at t is equal to 2 seconds. We can conclude sx comma sy at t is equal to 2 seconds is nothing but 120 and 140 meters. So in this way we can find the location of particle at any time just by using the, so you can try to calculate the same thing for 8 second. Again, up to 16 second we can calculate it, right? If you calculate at t is equal to 16 second, you should get the x as the range and y should be 0. You can verify all these things. At t is equal to 8 second, it reaches the maximum height where sy should be 0 and sx must be what, the complete range by 2. This is the location at t is equal to 2 seconds. t is equal to 8 second, it reaches the height maximum. Here see Vy is equal to 0. Okay, only Vx will be there. So if they ask question what would be the velocity at highest point, velocity is not 0 at highest point, because the average velocity is there, because finally some minimum velocity is there, constant velocity is there along x-axis. So we cannot conclude that velocity at highest point is 0. We can say that magnitude of the velocity or the velocity along y-axis is 0, but not the average velocity. Average velocity is there, or else we can say velocity decreases. That is the right statement. Velocity at highest point is 0 is a wrong statement. Again, velocity at landing point also we can calculate that one. Before we move over there, at t is equal to 8 second, what is the range? Range will be the r by 2. Okay, range will be the r by 2, and whenever it reaches here, horizontal distance will be the complete range, which has to be remembered like this. Now, okay, so if you have to summarize, we have studied about how to calculate the initial velocity and velocity at different time. Again, acceleration at different time in both the direction, both in x and y axis. And we have learned how to calculate the average acceleration, how to find out the location of what location of a object in projectile motion at any time, right? So in a similar way, next one is in terms of, okay, now velocity, we have written the velocity in terms of both vector and magnitude form. They can ask question both in vector and magnitude form. So in options, if you don't find I, j, cap and all those things there, that means they are asking to calculate the magnitude. Remember it very well. Okay, so suppose like u is equal to 60 I cap plus 80 j cap. Find the velocity. So if you have this type of option, that means they are asking to find everything in terms of vector format. If something is okay, u is equal to 100 is given. So if u is equal to in all the a, b, c, d, so that means we have to calculate the magnitude. We can remember like that. And we know one more fundamental concept, that dot product of two vectors, dot product of two vectors, dot product of two vectors is nothing but 0 when they are perpendicular to each other. Now the question is like, find the time when velocity becomes perpendicular to initial velocity. Find the time when velocity, so that means hmm, this is the initial velocity, right? This is nothing but initial velocity u. So suppose velocity, so this is u and this is v. At t is equal to, we don't know, whatever might be the x second. Okay, this is at t is equal to, when will they, at what time they will become perpendicular to each other. So for that we can use the concept of dot product of 0. So u dot v 0. At what time, at what time, for that we should know that u dot v is equal to 0. We can use that one. We should know how to write the u and v in terms of t as a function of t. This is 60 I cap, 60 I cap plus 80 j, because at t is equal to 0. But we don't know the time itself. Okay, so if we know the time, then we can find out v is equal to u plus 80, but we don't know the time factor over here. Now how to solve this one now? For that, simply, okay, vxi plus vy into j cap. Here we know that vx as we already calculated. If you just scroll up now, you can find everything, but I will show you that related to vy, uy plus ay into t, we don't know the time factor, whereas Vx it has no time factor because Ax is 0, so I got 60 I can remember that. Okay, Uy is 80 and Ay is minus 10, that is G into T. So write everything in vector format. So now we have U and V. Now you substitute that in, U dot V is equal to 0, right? So that is 60 I cap plus 80 J cap into 60 I cap plus 80 minus 10t J cap is equal to 0. Now dot product of two vectors has to be done. That is 60 into 60, right? 60 into 60, 3016. So then 60 into 60. Okay, we'll simplify this. No issues. Plus 80 into 80 minus 10t is equal to 0. So 3600 plus 6400 is equal to, we know 80 into 10t is 800t. If we shift that on opposite side, it will become plus 800t. So this is nothing but 3600 and all those things, that is 10,000, 10,000 by 800. So 800t. So okay, t is equal to 100 by 8. At t is equal to 100 by 8 second, this initial velocity and final velocity will be perpendicular to each other. Okay, exactly at t is equal to 8 second. That means suppose t is equal to 100 by 8 is here, so that means u is here in this way and v, so they are perpendicular to each other in this way. Okay, now the next question, find when velocity becomes perpendicular to acceleration. Now we just calculated that when velocity becomes perpendicular to acceleration, right? So in a similar way, next question, when velocity will become perpendicular to acceleration. So for that we have to use the concept of velocity into a is equal to 0. Velocity that we already written in terms of this one, you can recap it from here. V is equal to 60 I plus 80 minus 10t into j cap, right? V is equal to 60 I cap plus 80 minus 10t into j cap. We have to find the time when they will be perpendicular to each other. So v dot a is equal to 0, right? What is v? V is nothing but 60 I cap plus 80 minus 10t j cap into minus 10 j cap is equal to 0, right? All about simplification. That is 60. This is v, this is a, right? So, and if we can simplify this, 660 I cap into 10, that is minus 600, again plus 80 into and all those things. So just a second, minus 800 into, that is nothing but, just a second, v is 60 I cap plus 80 minus 10t into j cap into minus of 10 j cap. If we simplify this, we will get what? Minus 10 into 80 minus 10 into t, that is v dot a is equal to 0. So minus of 800 plus 100t is equal to 0. t is equal to 18 800 by 100, that is 8 seconds, right?